Welcome everyone to Grade 10 Mathematical Literacy. My name is Sashen Naidu. Today we're looking at models and we're practicing and doing some application questions. Let's stop talking about it, let's get to working. So, write instructions on how to wire a plug. Now this is important. Please do not, even in red here, bright, do not attempt to do this yourself. Always use a qualified electrician when dealing with electrics. All right, please, that is very important. Okay, we're doing this for practical purposes, but we cannot actually do this ourselves. So what is happening in step 1? I said we're using pliers, these things. All right, use pliers. Carefully bare the ends of 3 wires inside the electrical cord by cutting away the plastic insulation. All right, that's the first thing I'm doing. Now, please, boys and girls, when you're looking at these words that I'm using, as long as you're thinking along a similar lines and you can understand exactly where it's coming from, that's perfect. You don't have to say it exactly the same. You can use your own words, but of course, it has to mean what I'm trying to imply. That's important. All right, so we're stripping away the little plastic so we can get those ends. Nice. All right, let's look what's next. All right, so step 2, right up top here. Gently twist the strands of copper wire with your fingers. That's what we're doing here. Until each strand is tight. Okay, step 2. Now what do we see is happening at step 3? Remove the new plug cover by unscrewing it. So that's what they're doing there. All right, they're unscrewing the cover to separate into 2 parts. All right, we're working well. What's next? Unscrew the little screws on each of the plug's prongs. So the prongs, I'm just going to circle them. That's the 1, that's the 2, that's the 3 little prongs. And as you can see here from this one, okay, let's just use an arrow there. Okay, that guy is loosening those prongs, unscrewing them. Nice. Step 5, insert the twisted copper wires that we had in previous steps into the holes in the prongs. Perfect. Nice work. All right. What do we need to do now? Make sure that that doesn't come loose. We tighten like that. All right. We tighten the little screws on each of the plugs. Prongs. Okay. We're almost there. What's the final step? Replace the cover of the prong. Very nice work. So again, those are my instructions. If yours are similar, that's 100% fine. All right, try not to stray too far away from mine. Okay, now look at this. Tracy wants to put a decorative border around the edge of her paving. She wants triangles. Again, there we go. We've got to take note of our shape. With a base of 15 centimeters and a height of 30 centimeters. So we know those measurements relate to triangles. How many triangles can fit across the length of the paving if the paving is shaped in a rectangle measuring 2 meters by 3 meters and the triangle's base fits along the length of the rectangle? Okay, so before we get into that, let's just read this piece. Common error, not converting to the same unit. What does that mean? I'm dealing with centimeters here. The height of 30 centimeters. Let me just get rid of this line. Base of 15 centimeters. Right, but the paving is shaped in a rectangle measuring 2 meters and 3 meters. So there we can see the units of measurement are the same. We've got to do some conversions. Always do conversions to get all the units of measurement to the same unit. Very nice. All right, so to start off things here. Okay, just to do a rough little sketch so we have an idea of what we're doing. If that takes place if that line, represents the length of the rectangle, then we're going to have triangles fitted across there. That's one triangle, that's another triangle, and so on and so forth. We're saying that that measures 15 and that measures 15. Do you see that? It's fitting across the whole length. So the question, how many triangles can we fit across that length? So looking at that, the whole length measures 2 meters. There. That's where I found the 2 meters. So we can see now we've got to convert. All right, we have to convert. So what am I doing? I'm going to convert that 15 centimeters Let's take that guy. I've got to divide it by 100 and get that 2 meters, which is 0.15. Okay, so each one of those triangle spaces now measure in meters. Then, once that's done, I know it fits across a length of 2 meters. Therefore, 2 meters divided by 0.15 meters, and I get 13. Ooh, nope, that looked weird. 13, that's much better. 33 triangles. Now, looking at that, Matlot rounding off. Let's think about it practically. If I round up to 14, I'm going to try and squeeze in a triangle there, which I can't. The base won't be the same. So I need to round downwards. This gives me 13 triangles. Excellent. Nice work we got there. All right, let's go to the next one. So, next question. A tin of bistro coffee has a diameter of 100 millimeters, and we know when we say diameter, what shape are we thinking of? Circles. And a height of 120 millimeters. A cardboard box is 500 millimeters long, 300 millimeters wide, and 240 millimeters high. So before we get stuck into the question, take a look. All the units of measurement are exactly the same. There's no reason to convert this time. Nice. Determine the maximum, right, the maximum number of tins that can be packed into the cardboard box. All right, so here we've got to be very careful. We've got to realize that the cardboard box has a length of 500 millimeters, so there's a certain amount of tins can fit that way. It has a width of 300 millimeters. There's a certain amount of tins that can fit that way. And then, of course, it has a height of 240 millimeters. So we can stack tins on top of each other in a certain amount of, let's call it layers. So what we've got to break down here is we've got to see, like I said, we've got to see how many tins we can break in, or we can fit, along the length, how many tins we can fit along the width, and how many tins can we stack up high. And then we'd be able to figure out the total amount of tins inside here. All right, so let's get stuck into it. Let's get going. Length. All right, so across the length, we have 500 millimeters. That's the cardboard box. Now remember, the diameter here of 100 millimeters, that fits across the length. So if we have 100, and then the next one will be 100, and the next one will 100, and so on and so forth. We want to see how many times those hundreds fit into 500. So I must divide this by that 100, and that gives me 5 tins. Yay. Nice work. What will we do with the width? Similar thing. We've got to see how many tins can fit along the width. Now think about it. Again, with the diameter fits across the width as well. So, the box has 300, the diameter is 100, and I can stack, or fit, 3 tins this way, across its width. Nice work. So we kind of have an idea of what's going into the box. I've just got to figure out the height, how many tins we can stack on top of each other. So, the height now, let's think about it. The height is 240 millimeters for the box. But how high is a tin? A tin measures 120 millimeters. Therefore, 240 divided by that 120 should give me 2 tins. Wow. There we go. We're almost there. So we know the total amounts that can fit across the length, across the width, and across the height. Final step. Therefore, to fit across the bottom layer, we say the length times the width, and that gave me 15 tins. So I can fit in 15 tins at the bottom of the box. And then, of course, we've got a height of 2. Therefore, total amount of tins is going to be the 15 across the bottom multiplied by the amount of layers that we have, which is 2, and I get 30 tins into this box. Excellent work. Let's take a short break. When we get back, we'll pick up where I left off. See you in a bit.